Okay, this is the M1 paper from June 2023. It's question number 7, and this is a connected particles question on an inclined plane. We're going to be using dynamics. We're going to use some SUVAT to be able to work this out. But let's just read through all the information first of all. We've got a car and a trailer. One's 1,200, one's 600 kilograms. The angle sine alpha is equal to 1/12. The car's got a driving force, in this case 3,000. It's moving with acceleration 0.75. And then it tells me, this is quite unusual, it tells me what the two resistance forces are there. What it means is that I won't need to do F equals mu r on this question. And it says the car and trailer are both particles. Yeah, that's pretty standard. There's a tow bar between them with two tensions in there. And it says, using the model, can we show that the value of r is 60? Can we find the tension in the tow bar? And then part C is slightly different. We'll get there a little bit later on when we're looking at it. So first of all, let's stress the importance of drawing a good diagram out with this. I've already drawn a template out. Let's get going. Part A. So what have they told me in the question? They told me that sine alpha was equal to 1/12, and they also told me that the acceleration was equal to 0.75 meters per second squared. So I've already drawn a quick template out to help me. This diagram is really important, as you'll see. What I've got to do is put all my forces on first of all. So let's just focus on doing that. If we start with the car, the normal order I do it in is to put my weight acting down, which would be 1,200 G. I'll normally put my reaction force there, which I would normally call R, but they've used R already in the question, so I'm going to have to call it my normal force. And again, because there's going to be two of them, I'm going to call it my normal force NC here. The car has got a driving force acting up there of 3,000 newtons. And it told us that the resistance for the car was 2R. And then obviously we've got the tension in the tow bar, two of those, cancelling each other out, thankfully. Let's have a look at the trailer then. For the trailer, again, start off with the weight. That's going to be 600 G. Again, that's going to have a reaction force. Reaction force is, I'm going to call this NT this time. And the resistance due to motion is R there. Why do I know that R is going in that direction? Because it told me that it's accelerating, and it's accelerating up the plane with 0.75 meters per second squared. So just checking, yeah, I think that's all my forces on my diagram. What I want to do, obviously, is to be able to resolve in that direction, do F equals ma in that direction. So in order to do that, even though I don't know, I'm still going to put these on just because it's sort of what I standard do. For the 1,200, I'm going to say, well, that's equal to alpha. So this would be 1,200 G cos alpha. Don't actually need that in this question unusually, but I certainly still need that. That's 1,200 G sine alpha, resolving the weight 1,200 G. Now let's do the same thing for the 600 G. Again, very similar. Alpha, I'm going to get 1,200 G cos alpha there, and no, I'm not going to get 600. Apologies. 600 G cos alpha there, and 600 G sine alpha there. So let's just have a proper check of that diagram. Yeah, I'm pretty sure that's everything on there. And it's asking me in the question to show the value of R is equal to 60. So if I want to show R is equal to 60, what I'm going to do is I'm just going to resolve in that direction. F equals ma in that direction. What I'll have is the 3,000, the 2R, the R there, the 600G, and the 1,200G. I don't need to worry about the two tensions because they just cancel each other out. So I'm going to consider the system as a whole first of all. So consider system as a whole. Pretty standard for these types of questions. You consider all of it, then consider one of the two options. So resolve parallel to the plane. Which is F equals ma And then what have I got? I've got 3,000. I've got minus the 1200 G sine alpha. I've got minus the 600 G sine alpha. And I've got minus the 2r minus the r. All of that is equal to mass times acceleration. The mass obviously is going to be 1800, the two of them added together, times 0.75. How do I know it's that way round? If it's accelerating in that direction, then the 300 is bigger than all those other forces, even though there's 4 of them. And from this we can get r. It's the only variable that we don't know here, so let's just take our time to do this. This is 3,000 minus, or sine alpha is a 12th, isn't it? So let's just do a little bit, but not too much here. That's a 12th. That's a 12th. Excuse me. That's a 12th. Minus 3r. 1800 times 0.75 works out to be 1350. So we get 3,000 minus, that works out to be 150 G there, minus 3r is equal to 1350. So we get 3r is equal to 3,000, well, that's 1650 minus 150 G. And so r is all that divided by, or sorry, 3r is 180. R works out to be equal to 60 newtons. And I went through enough method there simply because it did say show it's equal to it, so I didn't want to jump too quickly to the answer. Then it says find the tension in the tow bar. So if I'm going to find the tension in the tow bar, what I'm going to need to do is to either consider just the trailer or consider just the car. It doesn't really matter which one you do. I'm going to go with the trailer, I think. So for part B, consider the trailer. I'm going to do resolve parallel to the plane again. So resolve parallel to the plane. I'm going to do F equals MA. So what have we got for this one this time? We've got T. Let's get rid of some of these highlighters and just explain it to you. Hopefully you're following along. For the trailer, T minus R minus 600G sine alpha. Okay, that's going to be equal to mass times acceleration. So let's write that down. It was T minus R minus 600G sine alpha is equal to mass times acceleration, but mass this time is just the 600, obviously, times 0.75. So that works out to be T minus, well, we know R is 60. We know that sine alpha is equal to a 12th, is equal to, well, what did that work out to be? That's 450, isn't it? Is equal to 450. And from that, we can actually just calculate it. T works out to be 450 plus 60 plus 50G, and that works out to be equal to 1,000 newtons. Excuse me, and then on to part C. So you just need to have a little bit of a think about this. So it says when the car and the trailer are moving at a speed of 12 meters per second, okay, so they're moving at 12 meters per second, the tow bar brakes. Given that the non-gravitational resistance to motion remains unchanged, use the model to find the distance travelled by the trailer before it comes to rest. Okay, so let's think about what's going on here. If we go back to part C, if we go back and look at this equation for the trailer, what we now know is that the tension is good. If it breaks, there's no tension force anymore. There's nothing dragging this thing along. So what I'll be able to do is to work out, using that formula, my new acceleration in here. Let's do it rather than try and explain it without having the formula here. So for the trailer, we know that T minus R minus 600g sine alpha is equal to mass times acceleration, but the acceleration isn't the 0.75 anymore because the t has gone. So that's my formula, and we know that t is equal to 0. So minus r minus 600g sine alpha is going to equal to 600a, and we know what r is, let's put that in as well, I guess, minus 60 minus 600g sine alpha. We know what sine alpha is as well, let's put that in. A 12 is equal to 600a. So a here is going to work out to be a negative, which absolutely, that's what we want it to do, don't we? Because it's going to slow down to 0. So if we tidy all that up, a works out to be minus 11 over 12, apparently, which is absolutely what I wanted, some sort of negative acceleration now. So doing SUVAT, we can just see what happens when this comes to a halt. So if I do my SUVAT, when did this occur? This occurred when the speed was 12, so when u was equal to 12. We're going to have it going down to 0 here. We know that our acceleration now we've just worked out is minus 11 over 12, and we want to know how far it goes. So I want an S there. Not interested in t. Which of my kinematics formulae uses S, U, V, and A? Hopefully you're on top of those. V squared equals U squared plus 2AS. So if we just sub all the information into this then, so we've got 0 squared, we've got 12 squared, we've got plus 2 lots of minus 11 over 12 S here. You can just rearrange that to work out what S works out to be. S works out to be 78.5, or rather 79 meters if I do it to two significant figures. Let's just go back. Yep, and then that's the answer to that part. So yeah, quite a long, detailed question for that one. Key was in getting a decent diagram, and then a lot of the rest of it was relatively standard stuff. Consider the system as a whole, work out some information, then just focus in on one part and see what's going on with that, and then a SUVAT at the end. Right, okay, hopefully that all makes sense to you.